Hello my dear children of class 11 science. Today again I welcome all of you through this mode of teaching, that is YouTube mode. And in today's class we will be starting new chapter, and this is the last chapter under unit number 7. Okay, and the chapter is surface tension. So under unit number 7, one more chapter that we need to cover up, that is surface tension. Okay, now to start this particular topic, that is called surface tension. Okay, let me just tell you that tension means the force. Tension means the what? Force. Now surface, as we know, it is usually the what surface? The free surface of the liquid. Now you know, like when we take liquid in a beaker, let me just consider there is a beaker out there. Okay, and if you fill the liquid in a container or beaker, then this surface in which we see is called what surface? Free surface. This is what surface? Free surface. Now this is completely filled up with what? Liquid. Now it can be of any liquid, like we can take water, it can be any other liquid, but most commonly we take with what? Water. Okay, now there is a surface, as I said, which is in contact with the what? Air, and that surface is called free surface. Now this free surface, okay, of a liquid, means any liquid, are in a state of tension. They are in a state of what? Tension. And this free surface exactly behaves like a stretched membrane. Stretched what? Elastic membrane. Okay. So if the free surface of the liquid which are in contact with air, this is air out here, this is liquid, okay, and they experience a force, and this force is called a tension, okay. But this surface of the liquid, as I said already, are in a state of tension and exactly behaves like a what? Stretched membrane. So children, as to define surface tension, it is the property of the liquid. It is the property of what? Liquid, by which the free surface, as I said, the free surface of the liquid behaves like a stretched elastic membrane. Okay, and this surface has a tendency to acquire a minimum area, the minimum possible area. Okay, now this free surface, actually, as I said, in contact with the air, behaves like a stretched elastic membrane, and this particular property of the liquid is basically called as surface tension. So to just write a point, that's why children, as you learn one of the chapter before this, that is called viscosity or the flow of liquid, that was also one of the property of liquid. Okay, now surface tension also one of the property of what? Liquid. Okay, but all the liquid does not have the same surface tension. Different liquid has different surface tension, as the surface tension can be measured also. We can measure, as is the property of liquid, but it is also measured. Okay, now before we come to the measurement of surface tension, let me just consider a surface. Let me just consider a free surface. This is the free surface of the liquid. So this is basically the top view. So we are just trying to see the liquid from the what? Top. Okay, so this is the free surface of the liquid. This is the what surface? Free surface of a liquid. Now in this surface I consider an imaginary line, just imaginary line. Okay, so because surface can be made by any number of line in any of the direction, but let me just consider that the surface is made of an imaginary line, and that imaginary lines I consider somewhere out like this. These are imaginary line. Okay, this type of line is called imaginary lines. Now I consider this imaginary line as AB. So this is the imaginary line. It can be any direction also. This can be this line also, this any of the part. Okay, but I consider this is the imaginary line AB, which is drawn in any direction. We have drawn in any direction in a liquid, as you can see in the diagram. Now the surface, this surface on either side of this line, on either side means either this side or this side, okay, exert a force. Exert a what? Force. And I consider the force which exert on this line, we say F, and even on this line the force exert is what? F. So this surface and on this imaginary line, okay, there is a force which basically exert, and this force is basically a what? A pulling force on the surface, and this force exert on both sides. And this force lies on the plane of the surface. So this is lying on the what? Plane of the surface, and exactly at right angle to the line. So I consider this line is an imaginary line, but the force which exert is always perpendicular or normal to the surface or to the line. But children, remember this part, this line we have considered in this direction. but this line can be in this direction also, any direction. But if I consider any imaginary line where it is considered on the surface, then there is a pulling force exerted on both sides of the, on either side of the lines, okay, and this force is always as perpendicular to the line. So under this case, this force is the force like the tension which act on the membrane part of the surface, okay. Then what membrane is like a stress elastic membrane, and this force exactly on the surface on a given length but act perpendicular to the line which we have considered, okay. That's why the surface tension is actually measured as the force, the amount of force per unit length, the per unit length in the plane of the what, liquid surface. The plane of the liquid surface is basically what surface? The free surface. So children, as I said already, surface tension is one of the property of liquid, but this is a quantity that can be measured also. And for the measurement of surface tension, so we can measure it as the force, the amount of force per unit length in the plane of the liquid surface, and this force which act at right angle on either side of the what line? Imaginary line. So if you look at this diagram, this is the free surface of the liquid, and on the imaginary line, the force which is acting on a certain length, okay, but always at right angle to the what, imaginary line, and this force per unit length is actually measured as surface tension. So children, remember this, surface tension is always measured as force per unit what, length, okay. Now the next thing that we need to keep in mind is this force, if you see, has a direction, because force is a vector quantity, and this force direction is, okay, always at right angle to the imaginary surface, and at the same time this force is also directed tangential to the liquid surface. So this is the liquid surface, but force is acting tangential to the surface. So I can just add another point, the direction of force. The direction of what? Force is tangential, okay, to the what surface? Liquid surface. So direction of surface tension is always act tangential to the what surface? Liquid surface. Okay, but as for the measurement, as I said, surface tension is measured as force, the amount of force per unit what? Length. Amount of force per unit what? Length. Now surface tension is a property of liquid, but is also a physical quantity, as I said, which can be measured. And it can be symbolically expressed by T. We can write T as the symbol of surface tension. Also, in some book you find the use of surface tension by the symbol S. So we can represent surface tension either by the letter T or by S. And you know, if the force is expressed by symbol F, and the length if I consider as L, then the surface tension T, or we can write S, any of the symbol you can use, is given by F by what? L. So force per unit length measure the surface tension. So force per unit length measure the what tension? Surface tension. So now we can easily guess what will be the unit. The unit means what unit? The SI unit. So we can express even the SI unit of surface tension. And we can write the SI unit in terms of the SI unit of force and the SI unit of length. And you know, SI unit of force is what? Newton. Length SI unit is what? Meter. So you can easily guess what is the SI unit of surface tension. The SI unit of surface tension is Newton per meter. Okay, what is it? Newton per meter. See, force unit is Newton, divided by length unit is meter, so it is Newton per meter. So this is the SI unit of surface tension. So after writing the SI unit, children, we can even write the dimensional formula, or we can simply call the dimension of surface tension. Yes, because you will be asked sometimes to write the dimension of what tension? Surface tension. Now dimension can also be written easily from the relation of surface tension, that is F by what? L. Because surface tension means force per unit length. They tell me what is the dimension of force. You have learned in dimensional analysis chapter, and the dimension of force is basically ML T minus 2. So children, what is the dimension of force? ML T minus 2. Now what is the dimension of length? L. Okay, now this L I'll take in the numerator, so it will be ML T minus 2. Now if I take this M in the numerator, there is power 1, but this power, sign of power will change. It will be N minus what? 1. Okay, so there is already 1 out there. So M, L 1 minus L plus 1, L minus 1 means what? 1 minus Plus 1 minus 1 means 0. So it will be L0 and T minus 2. You can leave it this way also, like dimension formula of surface tension is M L0 T minus 2, or you can simply write as M T minus 2, because any base with power 0 is 1. So we can simply write surface tension dimension by M T minus 2. So children, we have just done the introduction of this new chapter, surface tension, in this particular video. Now we do continue with other topic, okay, in this from the same chapter, and that you learn in the next YouTube video.